So having looked at the creational and structural design patterns, let's talk about behavioral design patterns. That is the largest group of patterns that we have. We looked at chain of responsibility, which essentially allows components to process information or events in a particular chain, and they can enlist themselves in the chain, and then they can also leave that chain as well. And we saw that each element in the chain, either it refers to the next element or you just make a list somewhere. So a very simple approach is you just make an ordinary list, you add every single element to that list, and then you go through the list with a for each statement, just notifying every element that here is an event that I've generated, please take a look at it. Then we looked at the command design pattern, which essentially encapsulates a request into a separate object. Now, as you probably know, requests come in two forms, at least in the modern programming world. They come as commands or as queries. It's a bit of an argument whether queries are commands or not. Now, the commands are good for things like auditing because you record every single thing that happened in the system. They're also good for replay, like if something anomalous happens in a system, you can replay the entire chain of commands and figure out how you got to this situation. And of course, a command supports undo and redo functionality, provided you code it, of course, because if you have all the saved commands, you can easily walk back the chain to undo things and walk forward to redo things. Now, a command is part of this idea of command query separation or command query responsibility segregation, and to some degree a query, now reminder, a query is where you ask for information. You don't ask an object to change itself or to perform some action, you're simply asking for particular information. Now, query is also effectively a command, and in certain situations, in addition to saving all the commands, you might actually be saving all the queries, because for example, if somebody is trying to hack your network by entering random passwords, trying to guess the password, you might want to record those attempts even though they actually didn't result in anything, because you want to detect a hacking attempt. So in this case, I would argue that queries are also part of the command design pattern as well. Then we looked at interpreter, which is actually a separate branch of computer science called compiler theory. We talked about the interpreter as a way of transforming textual input into object-oriented structures. That is used itself, the interpreter pattern, by obviously compilers, interpreters, various static analysis tools like ReSharper, for example, as well as many others, and it's not an easy subject. In fact, we have this hot topic called compiler theory. It's a separate branch of computer science, which is unfortunately not being taught at many universities, including many top universities, because there isn't enough demand for it, amazingly enough. So that is a very sad observation that I have to make. So if you want compiler theory in your computer science course, you might have to buy the books and study yourself. Then we looked at the iterator design pattern, and this essentially provides an interface for accessing the elements of an aggregate object. Now, we're lucky in the .NET framework because we have IEnumerable of T, which should be used in something like 99% of the cases in order to provide traversal. So in our case, in the case of .NET framework, the iterator pattern is not a class. It's rather a method which returns an IEnumerable of T, or it can be a property getter which returns an IEnumerable of T, which is the same thing because properties are methods in fact. So in the .NET framework, we have a very convenient way of actually building state machines using any method which has an IEnumerable of T in its return type and actually uses yield return or yield break for flow control. All right, let's finish off the behavioral patterns now. So we also looked at mediator, and mediator provides, well, just like its name suggests, it provides mediation between two different components. So for example, kind of message passing between systems or some sort of chat room, something like that. We looked at an example of an event broker as well, which is a central component. Now, one side effect of having a mediator is that everyone has to refer to that mediator, which is once again why dependency injection is so awesome, because with dependency injection, you can take the mediator, you can stick it, for example, as an constructor argument to the base class of your entire hierarchy, and then every single inheritor will obviously be forced to call the base class, and then you can use the dependency injection container to set, oh, here is my mediator, it's a singleton. Every time somebody wants an event broker, you're going to pass this singleton object in there, and that way you have all the components automatically initializing their singleton reference, their mediator reference, to refer to the mediator, which is very convenient. So one more advantage to using dependency injection. Then we have the memento design pattern, which essentially yields tiny little tokens representing system states, and those tokens don't really allow by themselves any kind of direct manipulation. A token is typically read-only, and sometimes you can actually hide everything that's inside the token. Unfortunately, it's very difficult to do in the .NET framework because you're exposing a public member, which subsequently needs to be used inside some system to revert to a system to a particular state. So in the .NET framework, tokens can be just have read-only properties, for example. So they can tell you what state the system will be rolled back to, but they don't allow you to change the token itself. So here the idea is that you don't do anything with the token apart from passing it back into the system whose state you want to roll back to the state represented by that token. So you need appropriate APIs for this. Then we looked at the observer design pattern, and the observer is kind of built in. It's built into C# with the event keyword. However, you do have additional support for the observer pattern as well. So for example, for properties, we have notify property changed. For collections, we have collections which actually also generate events, not just on elements being added, but also elements being removed and so on. And those collections, so we have things like binding list and observable collection and things like that. And finally, we have observable streams with the reactive extensions. Okay, so even more behavioral patterns now. We looked at the state design pattern, and that is essentially the idea that we model systems by having one of a set of possible states, and then we define the transitions between those states, and this is what's typically called a state machine. And you can do one by hand. We certainly looked at how to build a state machine by hand, but we also have special frameworks like Stateless, for example, and they exist to orchestrate state machines. So they exist as a way of giving you the API for defining the state machine and then for actually making the state machine do things. So we also looked at two very similar patterns called strategy and template method, and both of them define an algorithm blueprint or some sort of placeholder. So defining the high level operation and allowing you to customize this operation with your own different attributes. And strategy uses composition. So it tells you that here is the high level, but the low level has to implement this interface. And then you go off, you implement this interface, and you use composition by passing the object of that interface type into the strategy, thereby making the whole thing work. And a template method is different because it uses inheritance. So a template method is typically an abstract class with a non-abstract member, which actually defines the method of the sequence of steps to be performed. And then you have a bunch of abstract members being called, and you implement those abstract members, and that is how you get the algorithm to actually function. And finally, we looked at visitor, which is, well, generally it's the idea of adding functionality to existing classes and hierarchies of classes, and we looked at how to do it through double dispatch. Typically, the visitor pattern is used for traversal. So once again, you use the visitor to traverse some sort of hierarchy. For example, if you have a document tree and you want to print that tree in a particular format, you would transform every leaf of that tree. You would visit every leaf and you would transform it into something like HTML or Markdown, for example. It's also possible to use the DLR, once again, to build something called a dynamic visitor where you don't need the double hop, so you don't need the double dispatch. But of course, because we're using the DLR, because we're casting objects to dynamic, this comes with a fairly significant performance cost.